A two-dimensional incompressible frictionless fluid is guided by wedge-shaped walls. So, a two-dimensional incompressible frictionless fluid is guided by two wedge-shaped walls. Wedge-shaped. Into a small slot at the origin. So the flow comes from here this is VR and this is theta between both of them, pi by 4. Theta equals 0. So this is the flow. So a flow is guided by this wedge flowing in this direction. Now, the width of the paper is B and the volume flow rate is Q. Volume flow is equal Q. At any given distance from R. At any given distance R from the slot, the flow is radial inwards with a constant velocity. Find an expression for the polar coordinate stream function of this flow. So find psi in polar coordinates. Sorry, my polar is not just writing today, but no worries. So, we'll proceed in this manner. Recall that the volume flow rate Q is equal to the area, cross-sectional area of flow times the velocity. This will mean that the radial component of the velocity is equal to minus Q over A. Recall that the area is equal to A is equal to pi over 4, that's that theta RB. So if I put it in the formula, we would have minus Q over A is minus because it's radial inwards is equal to Q over pi over 4 times RB. Now, and this is equal to VR. Recall that VR is also equal to 1 over R do psi do theta. Therefore, I can write that psi is equal to the integral of Q over pi over 4 RB times R do theta. So R cancels out. This will turn out to give Q theta pi over 4b. Sorry, small b, and plus c, which is equal to Q theta pi b times 4 plus constant. Next, the question says, for a fully developed laminar flow, Vz is equal to U max into 1 minus r squared over r squared, comma, VR is equal to 0. Find the axis symmetric. We are looking for the axis symmetric side in terms of r and z. And then we will determine from this side the average velocity, V average, in terms of Umax. So we proceed in the same manner. First is to find the stream function, because we know that Q12 is equal to the difference of the 2 pi, the difference in stream 1, 2 pi stream 2. Okay, so sorry, this should be stream 2, this should be stream 1. Okay, so obviously we need to calculate psi first. So because that VZ is equal to Umax into 1 minus r squared over r squared, which is also equal to the standard formulation 1 over r to psi to r. Hence, we can write that the psi integral is equal to integral Umax 1 minus r squared over r, all in bracket, times r dr. So if I carry out this integration, we are going to have psi to be equal to Umax r squared over 2 minus r squared, r to the power of 4 over 4 r squared, hence plus fz constant. So this portion gives us the vz function portion, but we also know that VR is equal to 0, and it's also equal to minus 1 over r to psi to z. Therefore, we are going to differentiate the function we just got as to psi, and to differentiate it, you are going to have minus 1 over r 0 plus the f dz is equal to 0, which means the f dz is equal to 0. Therefore, f of z is a constant. Hence, we can put our equation in this form to be psi is equal to Umax r squared over 2 minus r4 minus r4 over 4 r squared. So now we go to find the q. Q is equal to 2 pi psi 2 minus psi 1, psi which turns out to be q is equal to 2 pi into Umax into r squared over 2 minus r4 over 4r squared minus this part is the psi 2 minus, because we are taking q from 0 to r, minus, put 0 on the other side, you have 0. Okay, put 0 inside the psi equation, you have everything equals 0. Therefore, we are going to have that q 0 to r from 0 to the radius is equal to pi over 2 r squared u max. This implies that the average velocity V average is equal to Q over A cross-sectional area of pipe, which means V average is equal to half, that is everything here divided by the area of cross-sectional area of pipe is equal to pi r squared. Okay, so if you put everything here, we are going to have half U max. Next, question number 4. An incompressible stream function is defined by psi of x comma y is equal to u over L squared 3xy x squared y minus y cubed, where u and L are positive constants. Find the volume flow Q passing through the rectangle surface Q through rectangle surface. So we proceed as follows. And the rectangle surface has the following coordinates: 2L00, 2L0B, 0LB, and 0L0. Okay. Show also the direction, the Q direction. So let's begin. We are going to have U is equal to psi to y, which is equal to 3u over L squared x squared minus y squared. This is what you get when you differentiate the psi with respect to y. For similarly, d is equal to minus to psi into x, which is equal to minus 6x squared u over L squared. Now, volume flow Q per width. If you get Q per width, we are going to therefore have that recall Q will be equal to Q over B will be equal to psi at 2L0, the lower point, minus psi at 0L. So I'm going to plug these two things into the psi equation. We are going to have u over L squared 0 minus 0 minus u over L squared 30 square L minus L cubed. And if you simplify further, that term turns out to be 0 minus UL. So minus UL times minus 1 is equal to UL. So that's what you get. And Q is equal to UL times B. This is now the volume flow. Since 2L0 is lower and has a larger Q and larger Q, then the flow is diagonal to the plane to the left. The flow is to the left, okay, because that side is higher than the other side, so it's flowing to the left, therefore, in this direction. Note 0L, 2L.